Hey, P-Physics 2 kids, it's me, Mr. CDS. Sorry you've had to wait so long to finally see me. I'm doing this video to kind of show you some applications of series circuits. This is going to build off of what you should have seen from terminal voltage. It's a slightly different topic, but it's really centered around the same concept. So I'm going to show you a series of demonstrations I did with the Cherry cohort to hopefully give you context for the tutorial you'll watch on voltage dividers. So it'll be a series of clips. I'm going to try to do it with myself and manipulating things at the same time. So I apologize in advance if things get kind of shaky with the camera work here. Okay, so let me turn my attention to the devices at hand. Okay, so let me show you the setup we have here. And it's in the dark for the reason we'll see. So I have a power supply set at a given voltage. So it's about close to 6 volts. I have some bulbs here. Right, a bulb board where I can connect up to 5 bulbs, and then I have a multimeter which will allow me to measure voltage and current. Okay, I'm going to focus on voltage for right now. So let me connect to here. Okay, so hopefully this doesn't overwhelm the camera. So we see we've got 3. Let's actually turn on the voltage. I've got 3 bright light bulbs. Okay, so I'm looking at the connections from the little metal clips here. I want you to ask yourself, are these connected in series and parallel, and how do you know? This is just a quick little review. So if you look at the connections, you've got going across, going across, going across. In other words, we have multiple paths that connect here. That indicates they're in parallel. And 2 things that tell us that they're in parallel is the brightness of the bulbs. They're all the same brightness. If I take one out, nothing changes about the other. In other words, each part of the parallel branch is independent of the other. Okay, that's not really the main focus, but it's a way for us to establish a contrast for what we're going to do next. Another important aspect of the parallel, okay, is if I connect a voltmeter across it. So I'm going to connect the voltmeter across one of the bulbs. All right, look at that. You see that it reads about 3.5 volts. And I changed this to about 4 volts. So remember, in a parallel circuit, the voltage across a particular branch should be the same as the voltage source. Now they're not quite the same because there's a drop across the wires, so we're going to ignore that wire part. So let me shift over here. So now I'm going to measure the voltage across the second bulb. And if you recall from last year, what should we expect about the voltage? And we see it's pretty much the same. Again, the wires are having some effect, so they're not quite the same, but they're close enough. So just as a review, one of the highlights of a parallel circuit is that the voltages across them are all the same. I know the voltmeter didn't quite give us the exact same thing, but it's close enough. Okay, so the main thing I want to do here is talk about series circuits. What if I were to connect these same bulbs in series? So I can do that with the plates by loosening them. So I'm going to have the voltage source come in from here. So I'm going to take away that path. I'm going to have it move through the bulb up through here and then go through this bulb. So I'm going to take away this path here. And then I'm going to have it, so I'm following here one after the other, and I'm going to have it end right there. So I'm going to make sure these are tight. I'm going to take my other lead and connect it right there. Hopefully I don't have any loose connections. There we go. So notice the light bulbs are lit, so I have a complete circuit, but in contrast to the parallel circuit, these light bulbs are barely lit. And so that brings up one of the disadvantages of a series circuit, is that when you put more and more bulbs in, you get actually less and less light, completely contradicting the idea behind putting more bulbs into a circuit. You think you'd get more light from that. So I want you to think about why that is. There's a number of ways you can address that. One is looking at the overall resistance of the circuit by putting 3 in parallel, or excuse me, in series, or looking at the voltage drop across each one. In fact, I want to do the voltage drop across. So to test the Kirchhoff's loop rule for this, to see what the voltage is across each bulb. Remember, in parallel, it was roughly the same as the voltage source, which was around 4 volts or so. But since we have 1, 2, 3 in series with each other, the rules for the loop rule is since there's 3 drops across all 3, across each one, there's a drop across each one, so a total of 3 drops, then we're going to take the voltage source and split it up 3 ways in order to satisfy that rule. So if I have one of the leads of the voltmeter right here, I'm going to place the other one on the other side, and I measure the middle bulb, I see that the Try that again. Just turned off on me. So I see that it is not reading. There we go, sorry, 1.0 volts. So it's getting 1 volt of the roughly 4 that we have on the source. If I go to the other side of this bulb, I see it's 1.2 volts. And if I go to the third bulb, it's 1.1 or so. So they're all pretty much the same. And when you total them up, you get 3.5 or so volts. So that's the loop rule there. So we can now understand why the bulbs are dimmer than when they were in parallel, because they're only getting a fraction of the voltage drop. The other thing I want you to recognize that's a disadvantage to series circuit is that when they're in series, if you take one bulb out, they all go out. Okay, that's the exact opposite we see when you have a parallel circuit. You take a bulb out, the other ones stay on. So this is giving rise to then, why would we connect things in series? And that's what the next few clips are going to be about. Okay, so now I want to introduce a new device or component to our circuit, and that's this. This is called a variable resistor. Okay, it's a big long tube, and the key component of it is this part here, which is a bunch of wire that's just wrapped around the core. About 400 or 500 times. So if I were to unspool all that wire, it would stretch all the way down the hall. So this is a resistor that is advertised, well, that's upside down, but that's 22 ohms. Okay, so I've got the voltage source hooked up to both ends, here and here, and I'm getting about 0.16 amps. So I take about my 4 volts divided by 22 ohms, and I'm getting, using Ohm's law, that value. So that's just a resistor. But that's not the main purpose of this is. I can then switch the connection to up here near the bar. Then I can do something pretty cool. So I'm going to, let's see if I can fit this in the same thing. I'm going to slide this bar here. And you notice that the current is going down. Okay, so when I slide it all the way to the end, I have very little current. And then when I slide it all the way down, I get more and more current. So what's going on? Well, if my current is changing and I'm not changing the voltage source, then I must be changing the resistance. And this is called a variable resistor. I can change its resistance by sliding this part right here. Now you might ask, why is this changing the resistance? Well, basically, if I go to the maximum all the way back here, okay, I'm getting my resistance from the full length of this wire. And so if you recall, resistance depends on length, amongst other things. Then the more length I have, the more resistance. And then when I slide it, more and more, let's say here, I'm only using the wire from this part. So I've essentially halved the length, not quite, so I've halved resistance, so I get more current. So that's what a variable resistor does. Now I'm going to show you in the next clip how we can use a variable resistor in a circuit to act as a voltage divider, which is really the main topic. Now, in our new setup, I've got the variable resistor connected in series with the light bulb connected to our voltage source. So I have a series circuit of 2 devices, the variable resistor and the light bulb. And if you look closely, the light bulb is not lit, but the voltage is on. So why is that? Well, this is the key to it. There has got to be 2 voltage drops across those loads, one across the variable resistor and then one across the light bulb, and they have to add up to the source. The source is about 4 volts still. In fact, I'm going to crank it up to 6 volts, or close to 6 volts. So, and we see that the bulb is now just barely lit. If I slide this, I'm going to slide it, and you can watch the bulb. You see the bulb gets brighter and brighter. Okay, so I have essentially a dimmer switch here. So I want us to understand why that light bulb brightness changes in terms of voltage drop or a voltage divider. And it works like this. The voltage drop, the current through both of these has to be the same. That's the junction rule as applies to a series circuit. So if there's a 1/2 amp here, there has to be a 1/2 amp here. If I slide it and it clearly getting more current, let's say there's now 1 amp, there's 1 amp in both places. So to calculate the voltage drop, I would use Ohm's law, where I'd say the voltage drop is I times R. So the voltage drop here is I times its R. The voltage drop across here is I times the bulb's R. If I is the same, different resistances will give us different voltage drops. So let's look at this guy when the bulb is very dim. When the bulb is dim, I'm using all the wire when the slide is right here. Okay, so if we're using all the wire, that means our resistance is at its highest. So if the voltage drop is I times R, and R is really large, then my voltage drop across here is going to be very large, leaving very little for this. So this has such a low voltage drop across it that it's not enough to draw current to get it to light up. So I've taken the 6 volts here and I've dropped most of it across here, let's say 5 volts. I'm not going to get the voltmeter out because it's too cumbersome, leaving 1 volt for here and not enough to light it up. So it's divided the voltage up. Now if I slide this to right here, so I'm only using this effective amount of wire, then my resistance has gone down, so by I times R, my voltage drop has gone down, leaving more voltage for this. More voltage for this allows more current, and so it's brighter. So that's how a voltage divider works. And so if I want to do a lab like we did last year, Ohm's Law lab, where I want to test how the voltage across this device changes or relates to its current, I need a way to change the voltage. Well, one way I could change the voltage is just simply change the dial here, but that's not always practical. So this is a neat way of changing the voltage, is by connecting a variable resistor in series, changing the resistance of the variable resistor, therefore changing the voltage across here. Okay, so if you have any questions about that, that should be addressed, hopefully again, or similarly in the tutorial. All right, one more thing I want to show you before I finish up. So the last circuit I want to show you is a little bit different. Instead of the light bulbs we're going to use, and it's hard to see there, is an LED. Okay, so I have an LED connected to another device right here, and they're in series, and again they have about 5 volts across it, and the LED is not lit up. It's not lit up because there's not enough voltage across it, right? Even though there's 6 volts across this, or excuse me, 5 volts across the circuit, there is less than 1 volt across here because of this guy. So this guy is offering a resistance much higher than this, such that the voltage drop across here is significant compared to that. So why would I do that? Well, let me lift this up. Okay, and you see that the LED has come on. So if I take this, whoops, and I cover it up, the LED goes off, and then when I uncover it, sorry, the LED goes on. So what I have here is a light sensor. This device is sensitive to light. When light shines on it, its resistance drops tremendously, therefore its voltage drop across it drops tremendously, leaving more voltage across here, and I can get it to turn on. If I cover it up, the resistance skyrockets, so the voltage drop across it skyrockets, leaving very little for that. And that's how all sensors work. You put a sensor in series with whatever you want to turn on or turn off, and then that sensor is sensitive to the environment. It could be light, it could be temperature. So you can build electronic thermometers that way, where the resistance of something changes with temperature. You can base it on stress for force meters or strain. So there's all sorts of environmental things that can change the resistance of an object if you're clever enough to engineer it, and that can change the resistance, that changes the voltage across it, changing the voltage across the device that you want to turn on and turn off, and you have yourself a way of switching things electronically, which is pretty cool. Okay, so hopefully these will make sense and will mesh with the tutorial.